Eta Carinae is one of the most intriguing sources in the sky, and there's actually a large group of us around the world that are keenly interested in it.
Eta Carinae is one of the most massive stars in the galaxy, and it is also a very evolved massive star that we think is near the end of its lifetime. It is believed to be about 90 solar masses, and it was thought to be a single star for the longest time, but it turns out that we know that it is actually a binary system, and there is a second star that we believe to be about 30 solar masses that exists in the system. In the 1840s, Eta Carinae experienced what we call the Great Eruption, where it blew out somewhere between 10 and 40 times the mass of our sun in material. And that material formed this nebula that now surrounds the system.
The nebula itself is a little bit large to map completely by Hubble. And actually we did that a long time ago with the Space Telescope Imaging Spectrograph. However, we were only able to see evidence of the dusty regions.
So the thing that we did is we had an international collaboration, and we used the Very Large Telescope in Chile to do spectroscopic mapping of the entire Homunculus Nebula. And what makes our mapping unique is that previously only about 5 slits had been used to map the entire homunculus, whereas we use closer to 100 slits across the entire length of the nebula to map everything, including very small details. This is one of the first times we not only have a 3D model for an astrophysical object, but we were actually able to take our 3D model and print it on a 3D printer.
What we find here is that there's dimples in the 2 lobes, here in the blue shifted, that which is approaching us, and in the red shifted section here. And then most peculiarly, in between, where we might expect to see something fairly symmetrical around here, we see these 2 wings coming out, tilted both with respect to the bipolar structure and with respect to the orbit of the 2 stars.
That gives us very important information about the physical mechanisms that are responsible for forming the nebula. For example, trying to determine whether or not it was a single star that had an explosion, or if the binary had some important effect on shaping the nebula.
This new model tells us that potentially the explosive event happened when the stars were closest to each other, and that the material that came out not only came out in the polar regions, but was shaped in the orbital plane, which is between these 2 systems. It tells us that the explosion event probably started on one side of the star and then propagated elsewhere.
Prior to these observations and the modeling, there was no reason to think that binarity played any role in the eruption or the forming and shaping of the homunculus. But now that we have this more detailed model, it turns out that the distance between each of these features is very similar to measurements that we have of the central binary. And so for the first time, we have evidence that binarity played a role either in the Great Eruption itself or in shaping the nebula after the initial explosion.